First off, welcome everyone. Thank you for participating this fine Friday afternoon. This presentation is led by me right now. I'm the PI of this NSF supported project, the Hour of Cyber Infrastructure, where we're aiming to help students, learners, instructors, staff, postdocs, and a variety of other folks develop what we call cyber literacy for GI science that we'll talk a little bit more about. My co-conspirators are Forrest Bolick, Karen Kemp, and Anand Padmanabhan, who are co-PIs on this project, and I definitely would be only spinning my wheels without them. So it's been fantastic. We also have a big project team that continues to grow. Many thanks to a lot of people for getting the project where it is. And hopefully getting us across the finish line, especially during a pandemics, which we can talk about some of the complications of that. So I like to start off just saying it's a big world. This is a slide that I like to use for a lot of presentations because I think it's pretty easy for us GI scientists, geographers, environmental scientists to forget how big the world is. I think one thing that's really changed in the last couple decades is how we actually look at the world. We've been filling it full of geospatial technologies, which many of us are very familiar with. Satellites, sensors, smart city, Internet of Things, cell phones, GPS, of course. All of these devices and all of this technology is now recording and streaming data 24 hours a day and has given us a different vantage point to really view the world. And one of the questions that is on a lot of people's minds is how do we actually unlock all of this new knowledge from this data? So we used to go out and we used to observe, we would issue surveys, we would question people in person. And that is a very useful methodology that's been around for a long time. And I think what we're trying to struggle with right now is what kind of questions can we ask and what can we do with all of this data, especially when the data grows so big that you can't actually look at all of it. You know, there's just so much data that you can't actually put your eyes on all of it. So we have to trust computers in order to actually kind of unlock and transform this data into knowledge. So a number of us put together an idea that we called cyber literacy for GI science as one way that we can actually start to understand all of this data. And just to back up, the idea behind cyber literacy is that it's one of many different types of literacies. And literacies themselves outline essential abilities and foundational knowledge. And importantly, these really changes society and science change. So the example that I like to give is financial literacy. This is something that we all need in order to operate, you know, our budgets and pay our rent, pay our mortgage, be able to buy groceries. So this kind of financial literacy is an important piece of knowledge that you need to know to operate in society today. Increasingly, as all of these cyber technologies come out, we are kind of advocating that we need to have this new cyber literacy in order for us to be able to unlock all of this new understanding. And we co-wrote a paper with a number of wonderful colleagues. I unfortunately can't list all of the authors because otherwise it actually takes up like half the slide. If you look at the paper, we have almost a full page of authors. It was an amazing project and paper to put together that actually took us 2 years to really craft. But I encourage you to check it out. We sent it out in the email and asked everyone to read it, but I realized that sometimes time gets away from us. But in the paper, we define cyber literacy for GI science as the ability to understand and use established and emerging technologies, which means the technologies that we've used in the past, such as traditional geographic information systems, GPS devices, et cetera, as well as these new emerging technologies, things like GeoAI, things like spatial data science and all the buzzwords and jargon that comes along with those. And the goal of those technologies is to help us as humans to transform all forms and magnitudes of that geospatial data into information. So boil down the data into something that we can actually use to generate new insights. And this is all to go for interdisciplinary problem solving. I think it's really hard to say that you can do the top two components without bringing in multiple disciplines. So this is kind of the idea of cyber literacy. And in the paper, we outline actually 8 core areas for cyber literacy. On the left side, we have 3 major components for GI science, which is spatial modeling and analytics, geospatial data, and spatial thinking. On the right side, we have computational science, which is comprised of parallel computing, big data, and computational thinking. What spans these 2 sciences on the technology side is something that we call cyber infrastructure. And on the people and problem solving side on the bottom is interdisciplinary communication, which is absolutely essential in order to share different ways of thinking, different ways of understanding in our theories. Cyber infrastructure might be new to some people, and we define it as the comprehensive infrastructure needed to capitalize on dramatic advances in information technology. So it's kind of the technology that we're using to host these lessons that you're going to have your hands-on demo today, as well as a wide suite of different technologies that are really starting to come into play. Either cloud computing or high performance computing and all of these kind of big buzzwords. We also break down each of these core areas into a number of themes. Thankfully for everyone, it's Friday afternoon. We're not going to go into the details of these. Please look at the paper if you really want to delve into it, but it's too much for a Friday afternoon, in my opinion. And along with all of these comes with a lot of jargon. And this is probably why a number of you signed up for the workshop and why many of you might be interested in Hour of CI, because a number of students come in and might be interested in something like cyber infrastructure or big data. And as soon as you do, you get hit by a mountain of jargon and buzzwords. And that really creates a barrier of entry for a lot of people. And then people ask, well, where do I start? You know, what makes sense? And that is really what inspired the project that we're talking about today, which is the Hour of Cyber Infrastructure, or Hour of CI for short. And the whole goal of the project is to build a nationwide campaign to introduce hundreds of diverse undergraduate and graduate students to cyber infrastructure. And we should actually broaden that a little bit, because part of our target goal is to also reach students in 2-year institutions that may not technically qualify as undergraduate students. We're very fortunate that NSF, Office of Advanced Cyber Infrastructure, has been supporting this project. It's almost $500,000. It's a collaborative project across the 4 PIs. It was originally going to be a 3-year project. We, of course, went into 4 with the pandemic. We started August 1 of 2018. And the project page is available. You have links to it in your email. So the big idea was trying to get learners to understand and appreciate both cyber infrastructure and GIS, geospatial technologies, and to give a really clear learning goal for students, which is just try it for an hour. And this was really modeled on a project called Hour of Code, which, if you haven't heard of, it's actually a K-12 initiative supported by pretty much every major computing industry company. And they've served over 1 billion lessons around the world, 1 billion, which is just a huge number. Just bringing coding to K-12 students. I've actually hosted it at my kids' school. I've helped kindergartners learn the basics of coding, which is just absolutely amazing. So we looked at that and thought, well, if we can teach kindergartners how to code, we can certainly teach students and faculty a little bit about cyber infrastructure and about cyber literacy for GI science. So the project is developing 17 lessons in total. And importantly, we're also developing supplementary curriculum material for the instructors, because we recognize, along with Hour of Code, that a lot of times the barrier isn't necessarily the students, it's that the instructor isn't always fully comfortable introducing topics that they don't have expertise in. So the idea of Hour of Cyber Infrastructure is that we can actually support the instructors as well and give you enough confidence in order to actually host an hour of CI or 2 lessons in your own classroom. The goal is to train over 100 educators and students. Of course, the pandemic has, put this up in a little bit of turmoil, but so far the adoption rate has been fantastic. So we're really excited. And then the instructor materials and all the lessons are all free, open source, Creative Commons released. The NSF project itself has 4 objectives. I'm not going to go into the details of these, but high level, we're going to develop 17 lessons. We've developed a gateway lesson and are in the process of finalizing 8 beginner lessons. We're going to be looking for lesson developers to help us develop the last 8 intermediate lessons. We're building on top of an existing science gateway called GI Sandbox, which I'll talk about in a little bit. And then we want to launch the process and train more than 500 students across institutions, science domains, backgrounds, races, ethnicities, genders, etc., in order to really get the idea out there. And then lastly, and very importantly, is to establish kind of a sustainable learning and instructor community. So hopefully we can kind of sustain this and bring together people who are interested in this, even as kind of the lesson development goes away. Hopefully the people who are interested in teaching it can continue. So what are these lessons? We are developing, or we have developed, a gateway lesson called Hello World of Cyber Infrastructure, little play on programming there. And then we're going to be developing a beginner and an intermediate lesson in each of the core knowledge areas, cyber infrastructure all the way down to spatial modeling and analytics. We're going to be looking for intermediate lesson developers. So if any of these interest you, if you really are interested in big data or geospatial data or anything in between, please let us know. And really, the whole project was trying to aim at meeting instructors and learners where they're at and help them to get where they are going. So we're offering in this project the first couple of steps, along with some resources on where to go from here. So that's what you're going to be exposed to in the lesson that we're going to be doing and all of the other lessons as well. What are the lessons? They're actually developed in something that we call Jupyter Notebooks. So I don't know how many people are familiar with this type of technology, but you can think of a Jupyter Notebook as a field notebook that, environmental scientists, social scientists might take out in the field. You jot down your notes and you kind of record everything. Computational notebooks, and the specific form is called Jupyter Notebooks, are the exact same thing for computational and data sciences. It allows you to put text, graphics, code, visualizations, and all of your data analysis in one computational document. It allows you to run code in the document, and it's a really powerful way of doing not only development, but as it turns out, lesson development for learning. So the basics of the lessons are really to boil down technical jargon and bring it down to the entry point where students are comfortable. So we use basic explanations and comparisons, trying to draw, actually using NSF's own definition of physical infrastructure to cyber infrastructure in order to kind of explain these jargon-filled topics in a way that students can understand. For example, the cyber infrastructure topic actually starts with catapults and Archimedes and builds up through the history of computing to get us to cyber infrastructure so that students can be very comfortable with the topics. One of the goals is to really build that community, as I mentioned in Objective 4. And we've been really actively learning from each other. So one of the questions that we generally have is, how do we actually teach this stuff to students and new learners, especially ones who might be a little apprehensive about the technology? And we have a big learner community saying, how do we learn this stuff? Because this is what's driving job opportunities for a lot of our learners. So we're trying to kind of go back and forth. And the way that the project is set up is that we have a best practices guide and a lesson development guide that's guiding the development of our lessons. The lessons themselves teach cyber literacy to our learners. Cyber literacy is tested by assessments that are actually built into the lessons themselves. And then that data actually provides us useful information to revise our best practices. So this is what our pilot project is doing right now. So where are we and what are we doing? Well, we have a phenomenal project team. So I'm talking, so unfortunately you have to listen to me, but I am not the brains of the operation. It's all these fantastic people and more. Unfortunately, I can't list everybody because the slide gets even longer. So pretty soon I'll have to make a blow up huge slide. In the before times, we actually had a in-person workshop at the Smithsonian Zoo in DC, and it was a phenomenal group of individuals. We did posters and we talked and had a great time at the zoo trying to figure out how we actually do this stuff. And now from that work, we've been working on the Gateway and the beginner lessons. And as kind of a little check-in, we've had one pandemic, which has really set us back because as you can imagine, all instructional folks who are leaders of instruction at their institutions got sidelined. But we've had 6 lesson developers, 12 supported pilot instructors. We've had well over 100 signups on the website, 1,200 user accounts on the pilot instance that include both learners and instructors. We've learned that we have a MOOC style kind of tail where some people will sign up and then not actively use it if they're volunteer, which we kind of expected. So not all of those 1,200 user accounts are active. But we have had over 175 learners actually take our questionnaire so far in our pilot. And overall, the lessons have been engaging and very relevant. What I'm really happy about is the kind of demographics and the diversity of learners that we've been able to actually reach. And this is all thanks to our pilot instructors, 120%. We've had just a phenomenal group of pilot instructors that have allowed us to kind of reach a wide number of students. In our questionnaire, we've seen over 25 fields of study, GI science, oceanography, environmental, social, law, everything in between. Our demographic representation, we had 40% of individuals identify as male, 48% identify as female, 1.1% identify as non-binary, 1.1% identify as transgender, and then 10% answering none. And then we had 44% individuals identify as white, 21% as Asian, 10% as Hispanic, 6% as Black, and 14% as none. So this was, and we've also had a great institutional diversity. So it's not just R1 institutions, which was our kind of big push, is to get it out to actually students who don't normally get access to some of these cutting edge technologies.